Hello, this is the Python lab submission, the video submission for the problem stated. The agenda for this presentation is we will understand the problem first and then define a solution approach. In this, I have followed two techniques. One is the two-pointer technique, another one is the brute force technique. We'll explain the step-by-step process on each of the techniques to get the desired output. And finally, we will be showcasing the Python code against these two techniques and which will be submitted against this presentation. Let's go into understand the problem. Understanding the problem. So what is the problem statement? A list that can contain positive and negative integers. We need to find two elements such as their sum is closest to 0. In simple terms, we have provided a list and two elements on this whole list which has to get sum closest to the 0. So for example, I have two test cases which has been inputted and I have used case 1 to solve via brute force technique and case 2 to solve via two-pointer technique. We'll see the technique details in the next slides, but right now we'll understand what is our input and what is the expected output. So in this case we have -4, +7, 6, 2 and -5. So out of this, if I add two combinations of two different integers, which one is closest to 0? For example, if I do -4 plus 7, it will be 3, which is not that close to 0. 7, 13, 6 to 8, 8 to 9, 4 to 2, whereas -4 and -5 is 9. So -5 and -6 is which is more or less close to what we are looking for, which is the closest to 0. And the output is expected as -5 and 6. The same goes for the bigger list, which is -50, 34, 19, 24, 33, 10, -46 and 38. The output should be of 38 and 34, which is 4, which is the two-pointer technique. We'll try to solve it. So without further delay, let's go and start explaining the techniques. So let's explain the brute force technique. So in this technique, it just possibly pairs all the elements on the list and calculate their sum to store the absolute value in a given dictionary along with the pair of elements. And finally, it returns a element which is a minimum absolute sum which will be defined on the program. This approach is a time complexity approach as it generates all possible pairs and elements, and this is less efficient compared to the two-point technique. That's why I want to put this first to explain in detail. Let's go the steps one by one. First is we create a dictionary and then we try to store each pair and the absolute values of it will get stored. The minimum sum as the variable will be initiated to positive infinity and minimum pair to none. So the minimum sum variable will be initiated to the positive infinity. So that means like we will sum the integers and we will get the positive infinity, and minimum pair will be kept to none. We will use for loops to calculate each sum of the pair which will be stored in dictionary D. We will check the current pair of the element is already in the dictionary and then calculate in the reverse order, which will be explained in the Python code. If the current pair is not in the dictionary, then it is added to the dictionary and absolute value of the sum is stored as a value. The current sum is less than the current, then it updates the current absolute value and it is update the current pair of element. Based on this, it will keep checking for the sum which is lesser than the current one. So as it gets the lesser value, it keeps it, the bigger value will be taken out. If that bigger value is come, we will just put minimum pair as returned. This is the way the brute force technique is ensured. Every time it just checks for the current value and it will compare with the current so that you can replace the current if it is nearer to the 0. Whereas two-pointer technique, which is the most efficient one, which uses time complexity of O(n), which is the second approach, and which is compared to this previous approach which was mentioned as the brute force technique. This is sorted first, the list is sorted first, then the two pointers is used. So first is we'll sort it, and then we'll try to create the end pairs on the final close. So here the list will get sorted first, that will be the sort method, and then the left way will initiate to the 0 and the right will be initiate to the length of -1. The left points in the first element are sorted list and the right points in the last element in the sorted list. So there is a minimum sum value which was initialized as 1000000 and minimum pair to none to keep the track on the minimum sum pairs. The code uses a while loop, will continue if the left is lesser than the right. In each iteration, the sum of the list left and the list right is calculated and stored in the sum variable. The absolute value of sum is less absolute value of minimum sum, then the sum is stored. The sum is stored in the minimum sum and the pair of the element left and right is stored in the minimum pair. If the sum is less than 0, the left is incremented. The sum is greater than 0, the right is decremented. If the sum is equal to 0, then the pair of elements left right is written, since it's a pair whose sum is closest to 0. And finally it returns the minimum pair is written. So basically the sort will help us to sort the integers in the sort order, and obviously in step 5 and step 6 it checks the minimum sum and it stores the right value, and if the sum is less than 0, the left is incremented. So based on this, it will be a faster approach to arrive the expected result, which is to find the minimum sum 0. So this is the difference between two Python codes which was written. So as we have speaking the brute force, which is more towards every time it just checks for the minimum sum by doing the pair combination one by one, whereas the two pointer technique is first the sort and then it starts comparing the current sum versus the minimum sum, and its left is incremented and the right is decremented. Based on that, we will get a minimum pair. So and both codes has given the result outputs as expected as per the test cases which was given expected output.